In this lecture, we're going to see how we can pass multi-dimensional arrays as function parameters. And we're going to look at an example straight away because I think that's the best way to really explain these things. Here we have a simple function which is going to do the sum of our array. It's going to return a double, and it's going to take a const double array. So it's going to be an array of const double types, and it's going to be a two-dimensional array because we have two angle brackets here. Notice that we don't have to specify the first guy here because it's basically going to be useless. It's going to be ignored by the compiler. It's going to be like the sized array we have passed to a function in a few previous lectures. Because the size and the first angle brackets here is going to be ignored by the compiler, we're going to have to pass the size as a second parameter here. And inside we're going to just do a loop to sum things up. This is a loop we have seen in two-dimensional arrays when we were learning about arrays. It's nothing special here. We're going to have an outer loop which is going to loop for the first dimension. We're going to have an inside loop which is going to loop for the second dimension. And at each iteration, we're going to be adding the current element to the sum variable here. And notice we are using array index notation here, which is really good and readable. But know that you can also use pointer arithmetic notation, which is really hard to wrap your brains around. I basically don't recommend you to use this in your code. It's going to be much more unreadable. Just use array index notation. Your code is going to be much more readable. But I just put the pointer arithmetic notation here for completeness. In case you see this out there, you're going to be able to recognize this. But I'm not going to try and explain it a little more because it's really confusing. You shouldn't use it. Okay, this is how you can pass a 2D array as a function parameter. We can also pass a 3D array, and again, the function here is going to return double. The name of the function is sum3d. It's an array of const double because we don't want anybody to be able to modify these elements. For the first element here, we don't really need to specify the size. Again, it's going to be ignored by the compiler, but you have to specify the other two. If you don't, you're going to get a compiler error. And because the first size here is not specified, we have to pass it as a second parameter to the function here. Once we hit the body of the function, we're going to do a regular loop. We're going to start from the outside. And when we hit the inside, we're going to use the array notation like we do here. And we can also use pointer arithmetic. And again, this is mentioned here for completeness. I don't recommend using this in real code out there because it is a headache to really wrap your brain around. Just use the array index notation. It's going to be easier to handle. And we are just going to keep looping around, adding whatever element we are at to sum. And when all these loops are done, we're going to have our sum stored in this sum variable here. And we're going to return it to whoever called this function here. Okay, now that we have the functions set up, we can see how we can call them. We're going to set up two arrays. One is going to be called weights, and it's going to be a 2D array. We're going to initialize it like this. We're also going to set up a 3D array like this, and we're going to call our functions using std size to deduce the size of these arrays. This is nothing new. Now we're going to head over to Visual Studio Code and actually try this. Okay, here we are in our working folder. The current project is multidimensional arrays function parameters. We're going to grab our template files like we always do, and we are going to put those in the current project, which is multidimensional array function parameters. And we are going to open this in Visual Studio Code. And we're going to have our main function here. The first thing we're going to do is go below the main function and put in the definitions for our functions here. And we're going to grab each of these guys and use that to set up a declaration in front. This is something we might do. Let's get rid of the left pane here. It's just taking space that we could use to do better. Thanks. We're going to copy the sum3d function and we're going to put that in front of the main function. And we're going to add a semicolon, and this is going to be our declaration. Let's say that these are our declarations. And down below main, we're going to have function definitions. Please note that if you want, you can put these functions in separate files. If you don't know how to do that, please check the lecture where we talked about multiple files in this chapter. You're going to see how you can do that. Now we're going to look at these functions here. The first one is going to sum up a 2D array. The syntax is what you see here. You say the type that you store in the array, you say the array name, and you put angle brackets in numbers that specify your dimension. Here we have 2 angle brackets. So this is going to be a 2D array. We're going to do the same for a 3D array. And notice that we have 3 angle brackets, denoting that this is going to be a 3D array. The first index here is ignored because the compiler is going to ignore it. So we might as well ignore it to make our code much more readable. But we're going to specify the first index here, or the size of the first index, through a second parameter that we pass to this function here. And the type is going to be size t because this is going to be a size. Now that we understand the function declarations, we can go down and analyze the function definitions here. And we are really doing nothing special. We are setting up a variable which is going to hold our sum. And we are just looping through the elements of the array the same way we've been doing for 2D arrays when we learned about 2D arrays in the arrays chapter. Once we hit the correct element, let's comment this out and activate the array index notation. Once we hit the correct element, we're going to grab it and say array ij here in this angle brackets, and the value is going to be added to sum. We're going to keep looping until we have added all the elements in the array to sum here, and the sum is going to be stored in this sum variable, and we're going to return it. We are basically doing the same for a 3D array. The only difference is that this is going to have 3 dimensions. We are going to loop 3 times. We're going to have 3 levels of nested loops, and once we hit the element we want, we're going to add that to our sum. That's the syntax we use here. And you see that we say array ijk here because we have 3 dimensions in our array. If you want, you can use the pointer arithmetic notation here, and you're going to see that it is going to work. But we are just going to use the array index notation because it is just easier to handle and work with. Now that we understand the function declarations and definitions, we can head over in the main function and set up arrays that we can sum up. Let's put in the code to set up and initialize our arrays. Weights is a 2D array, which is going to have this data inside. Weights 3D is another array, which is going to have 3 dimensions, and we initialize that with the data we have in here. Now that we have these guys, we can actually use them. We're going to set up a double result variable, and we're going to store in the sum of our 2D array. So we're going to say weights in here, and we're going to say std size weights. Okay, this is going to store our sum in result, and if we print it out, we're going to see it on the console. Let's do that. Std cout, and we can build and see what we see when we run this application. The build is going to be good. We can clear and set up a new terminal, and clear and run Rooster. We're going to have our sum in here, and if you take your time and sum all these elements up, you are going to get 780. We can go down and try out our sum3D function. We can do the same thing here. So we're going to grab result here. We're going to copy this, and we're going to say result equals sum3D. 3D, that's what we're going to choose. And we're going to say weight 3D. We're going to copy that and put that here. And we're going to say std size weights 3D. And we can print the sum out. And if we build, let's see if the build is good. The build is good. We can clear now and run Rooster. Now we are going to see that the sums are the same for a 2D and a 3D array. Let's double check and see that we have the same elements inside. So we have 10, 20, 30, 40, 50, 60. That's what we have here. 70, 80, 90, 100, 110, and 120. And we have the same elements inside. And this hopefully proves that we are right. This is going to give us the sum of the elements in the arrays here. And this is really how you can pass multi-dimensional arrays as function parameters. We are going to stop here in this lecture. In the next one, we are going to learn about default function arguments. Go ahead and finish up here and meet me there.